Hello everyone, I am David Löh, Editor-in-Chief of Inspect magazine. Today I'm talking with Michael Zapke. He is the marketing lead industrial of the Adaptive and Embedded Computing Group at AMD. In the next few minutes, we will talk about the embedded vision industry, how AMD plans to lower the barriers to entry into the embedded world, and what new developments we can expect. Welcome, Mr. Zapke.
Thank you very much, Mr. Löh. Looking forward to our interview.
Me too. So, how do you assess the development of the embedded vision market?
Well, the embedded vision is an essential element for the productivity through automation. And that's, of course, why it's interesting for me in the industrial segment. Automation applications often use several optical sensors, not only one at the same time. So that of course, enables more evaluations. And especially when you think of machine learning and artificial intelligence, of course, the embedded vision, especially the embedded vision, plays an important role for us. The connection of all of that, basically, to have that all embedded in a system on chip, that is what we call intelligent edge. And that is what my daily work is about.
I see. And what are the most important target markets for AMD in this field?
So I'm primarily talking about industrial vision, healthcare, and sciences. That's where I'm from. Of course, automotive and the other businesses have also applications, but let's focus today on industrial. A central aspect is, of course, industrial vision. That is everything that has to do with production automation, with process automation. And of course, that includes also building automation, automation in agriculture machines, in railways, and much, much more. I believe this is probably my main target market, but when I ask my colleagues, they would also, of course, mention smart cities. And smart cities is the public area, it's security cameras and all that. And I think embedded vision plays a role there as well. And the third thing that I would like to mention is the wide range of imaging processing in medical technologies, where embedded, of course, plays a role just because of the size and the intelligence that is needed for this kind of applications.
Okay. And AMD recently introduced the ODM ecosystem program based on the Kria system or module platform. Can you please explain what the program is all about?
Yes, sure. Let me start probably with explaining what we have under the product name AMD Kria. Maybe not everybody knows it who listens to us.
Sure.
So we offer system on modules. We call that SOMs, or everybody calls it SOMs, with the AMD adaptive systems on chip and the peripherals on a small plug-in board. And the idea behind it is, of course, to make it easier for users to apply SoC system on chips. And the most difficult part of the hardware development is, of course, to do the breakout around the complex chips and do all the memory applications and all that. And this is what we have solved. And as a supplier of such a system on module, we also take care of the selection and buying the devices, the components that we need around the SoC. So we make things simpler. And that was now about the SOM, not about the ODM program. Now let me talk about the ODM ecosystem. The ODM ecosystem builds on exactly that. Companies use AMD Kria, our system on modules, develop complete products with that. And of course, they address the common target markets that our partners and we as AMD have. So working together here is also a chance to do common marketing. So we can use our channels, our partners can use their channels, and we address, of course, those customers in the target markets that we were talking about. And that is a further step to make the use of AMD technology easier for customers. And it's, of course, for us, one thing that helps us to cover the full range between buy and make. You know, there's always a make or buy decision. And to cover everything between doing everything in the own development, everything from the PCB to the software application to buy a finished product, I believe that range has all its targets in the industrial market, and the better we can cover it, of course, the better we can serve our customers. That's what we want to do. And of course, what we expect these users of ODM products to do is to get a feeling about what SoCs from AMD can do. So we have this, of course, as a thought to make that easier to understand, to create new ideas around our technologies. And at the same time, of course, we want to also encourage our partners to think more about it, what could be probably resonating with our customers. And we go with that, of course, also to the public. For instance, just recently at the trade show Embedded World in Nuremberg, which was in mid of March, I believe.
Yes. Okay. Yeah. But it's not the first attempt of AMD to lower the barrier of entry into the embedded world. Mm-hmm. I don't mean the trade fair, but the embedded systems world, of course. So one example is the Korea KR260 robot starter kit. How does this differ from the ODM ecosystem program?
So these are indeed two different steps. The robotic starter kit is our entry point for smart factories. Actually, there is another one, the Korea AI Vision starter kit, which we released already earlier, which is the entry point to smart cities and smart factories. That is what I started with as a definition for the target markets. So with the starter kits, I think that the users get hardware with the right interfaces, and in addition, some example applications that they can use just to start with, just when something is on the table, that it does something meaningful. So that is the starter kit, and you can start developing as a user from that basis. You can take the hardware, you have the hardware interfaces, and when you've done that, when you created your applications, of course, you can take the SOM from the starter kit and put it on your own carrier card, so that the path to the finished product with the SOM on it is significantly faster than having nothing or having no starter kit. When we talk about the ODM program, it follows the same path, but exactly what I described is done by the partners. It's not done by the end customer, it's done by the partner. And it contains then, of course, also already the integration of the carrier board and a special carrier board for that purpose, and the software, the application, so everything comes together. So it is another step towards buy, actually, in this make and buy range, to go more towards buy. That is our idea with the ODM system.
Okay, I see. And what are the benefits for the users and developers?
Of course, when we talk about the participants of our program, what they try to do is to aim at products with innovative functions which go beyond the normal by using intelligent system on chip and the programmability of our devices, so that they address, of course, user requirements well. We're convinced that the architectures that we have on the SOM and on our devices are good for software applications that can adapt to the user's needs. And that uses, of course, the programmability of software. Software is always programmable, but programmability of digital logic, the FPGA portion, you know, that we're coming from there. That is, of course, DSP functionality that you can program. There are, in some devices, vector processors that we have. Probably this is also something that can be done in programmable logic. And of course, the IOs are programmable as well in our devices. So actually all is programmable, and the benefits is you can adapt it to what the customer basically really needs. And I think that the manufacturers of these ODM products simply bring in significant experience to produce marketable products. We are producing devices and boards, but these companies know how to build a product with housing, with everything around that. And of course, that's an advantage in terms of effort and in terms of time for the end customer. And let me add as a last thought, these approaches also allow combinations of AMD technology with leading other technology that doesn't come from AMD. There's nothing wrong with that. When there is Korea in the middle and there are other devices around that, other components around that, which help to address applications, that's great. Of course, that's what we want to see. We want to see really companies that do the best out of our technology.
Okay, of course, I can imagine. You mentioned it already, but AMD already has several partners on board that supply ODM products. Can you give examples for applications they support?
So we started with 3 applications with some companies, and these 3 applications are, of course, around intelligent functionality in industrial and vision. The first is an industrial IoT gateway. I see our specialty of our devices that we are very, very flexible when it's about data acquisition. And an industrial gateway, an IoT gateway, is something that is doing data acquisition. So collecting data from multiple sensors and bringing that into a form where you can process data, illustrate data. That is, of course, a very, very relevant application in industrial IoT environments. Our partner Actron, they are situated in the USA, in California. They developed such a gateway based on Korea with an own carrier board. Second is what we call AI Edge Appliance. The AI Edge Appliance is a device that can process 8 HD video streams simultaneously and perform detection tasks on all these streams in parallel, not one after the other. It runs all in parallel. And this uses our capability of doing pre and post processing on multiple streams in our devices on Korea right at the same time. And we basically have found here with the company VVDN Technologies, a company who brought that together with in a small box, in a small box that has the Ethernet ports that can run that all at low power. Actually, it is a pretty big function in a very small enclosure. And the third is industrial smart cameras. Here, of course, we are going for cameras that are programmable to a user's task. So the camera has the capability to adapt later. It's a serious product, but with adaptation capability. And this camera comes with 1 gigabit and also with 10 gigabit interfaces. So actually, there are applications that need the bandwidth, the accuracy. And Automotive is our partner who is doing that application. These are the first 3. And in short, there are 3 areas or 3 applications which address the core area of what I outlined in the answer of your first 2 questions, I think.
Yes. Okay. Thank you. That really sounds very interesting. So besides that, what else can we expect from AMD in the near future?
So in the near future, we basically built on what we have done already with our system on module that we have today. I'm not sure if we mentioned that already. The current system on module that we have is K26. That is the product name of it. And K26, it sounds already as if there will be more and more numbers, and that is actually true. The current device has a powerful quad-core SoC and programmable logic, which is sufficient for advanced algorithms. And that leaves us, of course, room to go a little bit towards the cost-optimized direction or in the cost-optimized area, and also to move a little bit more to the high-performance area. And both is what we intend to do. But today, unfortunately, I must hold back a little bit with details about what we're doing. But what I can say is we will announce more about the cost-optimized module later this calendar year. So in 23, you will hear more about that particular device. And of course, I'm looking forward to tell you and everybody more about it when it's the right time.
Okay, I'm looking forward to it as well. Okay, thank you. Is there something you want to add or mention? What you didn't
So
mention again?
I think maybe when we're looking forward to the applications that we want to address, I started with the term intelligent edge, and all what I said was somewhere around intelligent edge devices in an IoT environment. And this is what you can expect from us, that we continue with that idea to have edge devices, intelligent cognitive edge devices with machine learning, with AI. And when we extend that now, we will go, of course, to this area and its environment. So when you look between what can be useful between cloud, edge, and endpoint, there is a lot around the edge devices that helps us to connect better to clouds, or to fill this gap a little bit, to connect to endpoints or realize endpoints. And I think this is just showing you a little bit the way we're thinking. This is the direction that we plan to go. And of course, we'll listen well to our customers, to the markets, also what we hear from you, to get the inspiration to do the right things. So that's, I believe, what gives you a good idea where we're going.
Thanks for that. Okay,
Welcome.
so thank you for this very interesting talk, and I wish you a very, very good day, and yeah, see you on the next Embedded World at the latest.
And probably at SPS Drives or SPS later this year. Thank you very much for the interview. I really appreciated that.
You're welcome. Bye.
Goodbye.